You hear people throw around the words data and information all the time, right? A lot of us kind of use them interchangeably. But in the world of computers, they are worlds apart. And honestly, getting this one difference is the key to understanding the real job of every single computer out there. So let's dive in.
So take a look at this, 98.6. What does that mean to you? Right now, it's just a number. It's a raw fact kind of floating there with absolutely no context. It's a complete mystery.
I mean, seriously, could it be a really good score on a test? Or maybe it's the frequency for your favorite radio station. Could it be a price? Or what if it's something more important, like a patient's temperature? The point is, without knowing more, this number is basically useless. It could be anything.
And that feeling right there, that sense of what is this, that gets right to the very heart of what we're talking about today. That ambiguity is the fundamental difference between data and information. Let's break down exactly what sets them apart.
All right, first up, let's talk about data. The easiest way to think about it is as raw, unorganized ingredients. It's just a collection of facts and figures and symbols with zero context. That 98.6 we just saw, that's pure data. A random list of names like John and Sarah. Data. All those barcode numbers getting scanned at the grocery store? Yep, that's data too. It's the starting point for everything, but by itself, not very helpful.
And then we have information. Now, this is what you get when you take all that raw data and you process it, you organize it, and you give it some real context and meaning. Information is the finished product. It's the useful stuff that actually answers a question or helps us make a decision. So let's just boil it right down. Data is the raw input, completely lacking context. Information is the processed output, which actually has meaning. Here's another way to look at it. Data is the question, information is the answer. So how does this amazing transformation from useless to useful actually happen inside a machine? Well, let's use an analogy that I think makes it super clear. Baking a cake. I know it sounds a little silly, but it's a surprisingly perfect way to picture what a computer is doing every single moment it's powered on.
Think about it. You've got your raw ingredients, flour, raw eggs, sugar. That's your data. You're not just going to eat a raw egg, right? The act of mixing it all together and putting it in the oven, that's the processing. And that delicious, finished cake that you can actually serve and enjoy, well, that's your information.
Okay, so if data is the ingredients and information is the cake, then what's the computer in all of this? The computer is the entire kitchen. It's the oven, the mixing bowls, the countertops, the whole system that is perfectly designed for this one crucial job, turning raw stuff into something amazing.
All right, so let's take a little tour of this computer kitchen, shall we? The very first step in any recipe is, of course, to get your ingredients. For a computer, this means getting that raw data into the system in the first place.
This is the job of what we call the input unit. Devices like your keyboard, your mouse, a scanner, or even a microphone. They take what we do out here in the human world, typing, clicking, speaking, and they translate it into a language the computer can actually work with. They're basically the front door to the kitchen, letting all the groceries in. So once all that data is inside the kitchen, it's time for the real magic to happen. It heads to the heart of the entire operation, the place where all the baking gets done, the processor and its workspace.
We're talking about the Central Processing Unit, or CPU. Now, you've probably heard it called the brain of the computer, which is a great way to think about it. But in our kitchen analogy, the CPU is the master chef. It's the one doing all the heavy lifting, following the recipe, which is just a set of instructions, to transform those raw ingredients.
But see, our master chef isn't just one person. It's more like a two-person team. First, you've got the control unit. Think of this as the manager or the head chef. It's not doing the chopping, but it's directing traffic, telling all the other parts of the kitchen what to do and when. Then you have the arithmetic logic unit, or ALU. This is the chef who does the work, all the math, all the calculations, all the logical comparisons. And any chef, no matter how good, needs a countertop to work on, right? A place to put the ingredients in the mixing bowls. That's memory, or what you'd probably know as RAM. It's the workbench. It's a temporary space where the CPU keeps all the data and instructions it's working with right now. It's super fast and absolutely essential for getting the job done efficiently.
Okay, so the ingredients have been gathered, they've been prepped, mixed, and baked. The cake is ready. Now we just need to get it out of the oven and onto a plate so we can actually, use it.
And that is the job of the output unit. Devices like your monitor, your printer, or your speakers, they take that finished product from the chef and turn it back into a form that we humans can understand. They serve it up to us as text, pictures, or sound. It is the final and maybe most important step in the whole process.
Which brings us all the way back to the beginning. Remember that mystery number we started with? That lonely piece of raw data?
Well, after going through this whole kitchen, input from a thermometer, processing by the CPU, and output to a screen, that raw number, 98.6, is completely transformed. It's been given context. It's not just data anymore, it's information. The patient's body temperature is 98.6 degrees Fahrenheit, which is normal. Now that is something you can actually use.
At the end of the day, if you remember just one thing from all this, it should be this. A computer's entire reason for being, its most fundamental purpose, is to perform this one transformation over and over again, to take in raw data, process it, and give us back useful information. That's the whole game. Think about it. Every single time you click your mouse, type something into a search bar, or use a sensor on your phone, you are creating new data. It really makes you wonder, with all of this raw data being generated every single second of every single day, what incredible new information is just sitting there, waiting to be discovered?